Welcome everyone to the October 2011 Sangamon Valley.net user group presentation. Our speaker tonight is a local consultant and professional .NET developer. He received his Bachelor of Arts degree in computer science from Illinois College in 1993. He's worked as a consultant for LRS. He's worked at ISB. He even spent a stint in management over at TRS because he's a good sport, and I would hope that currently he's working over at Horace Mann on the SAW team as a developer. He's doing TFS work for them right now, which plays into our topic tonight, and is also working with them on their Agile best practices. I hope you'll join me tonight in welcoming a heck of a nice guy and a great developer, Scott Hembrough.
Thanks, everybody. As Alan mentioned, I've been working at Horace Mann for about a year now, and I've gotten quite a bit of experience with Team Foundation Server 2010, and I've also had the opportunity to work on some Agile development teams where we've implemented some best practices such as test-driven development, which Jim Doherty talked about last month. And we also have implemented a continuous integration process, which I'm going to talk about this evening. So specifically what we're going to talk about tonight is we're going to talk about using Team Foundation Server 2010, or TFS as I'll call it the rest of the night because that's a real mouthful, to implement a continuous integration process on your development team. So let's first talk about what Team Foundation Server and continuous integration are, just to make sure we're on the same page. Team Foundation Server is a Microsoft product. It's a server-based product that is really a core component of Microsoft's application lifecycle management tools. It can also be described as a platform for collaborative software development. And once you really get your hands around what TFS is all about, then you really start to understand the depth of that statement. TFS has features for just about everyone. For developers, which is what we're most interested in, you've got version control, build automation, execution of unit tests, and even automated deployments to remote servers. For your business users, maybe your quality assurance staff, you can set up SharePoint-based project portals that they can connect to get to their documentation. Can also get to their test cases. They can manage test cases. They can enter bugs. And finally, for the project managers and project facilitators out there, there's extensive reporting capabilities with TFS. So if they need to report on project health or project status, they can easily do so with the built-in reporting capabilities. And those reports can be customized as well with a little programmatic help. But what we're going to talk about specifically tonight are the developer-oriented features, which are version control, the build automation, unit test, and deployments. Now let's talk about continuous integration a little bit. Continuous integration, I think, is best defined by a prominent voice in the Agile community by the name of Martin Fowler. And he defines continuous integration as this. Continuous integration is a software development practice where members of a team integrate their work frequently, usually every day, leading to multiple integrations per day. Each integration is verified by an automated build, including test, to detect integration errors as quickly as possible. So many teams find that this approach leads to significantly reduced integration problems and allows the team to develop cohesive software more rapidly. So in a nutshell, he's basically saying everybody on the development team brings their code together, ideally every day, and they compile the code, they test the code, and they verify the results. And obviously, if there's a problem, somebody has to jump in and take care of it. So if you think about that, if each developer were to do that manually, it'd be a pretty expensive process. So that's where TFS comes in. TFS will actually automate the majority of those steps. So when a developer checks in his code, TFS will capture that event, and it will do the build for you. It will do the execution of the unit test, and it will verify the results and report back to the developer, success or failure. And it can even go as far as deploying, deploying your source code out to a remote server, such as a web server. So some of the advantages that you'll see with continuous integration, since everybody's bringing their code together every day, you're going to have immediate visibility to the impact of your code changes on the overall code base. So again, so you can fix any problems right away. It should reduce the impact, the overall impact on your project schedule. Because if you think about it, if you catch the integration issues early, and they're very simple to resolve, you're going to be spending a lot less time taking care of that situation than if you wait till the end of a release or even the end of an iteration where you have to bring that code together and possibly have more complex integration issues to deal with. Another advantage of continuous integration, your code should always be in a releasable state. So assuming you're following best practices, you check your code in every day and you've got a suite of unit tests that will run against that code, and you're adding unit tests as you go along developing your application, you should have a pretty high level of confidence that the code that you put into your source control is going to be ready for your testers to test and report back on right away. And finally, continuous integration promotes communication and collaboration between your team members. Now, no offense to anybody out there, but as developers, we're not the strongest communicators in the world sometimes. I know I've been guilty of that myself. But if you check in code and it breaks the build, you're going to be forced to work with other members of your development team and to resolve those problems. And in the end, that benefits everyone. Oops. So at this point, why don't we dive into the details and we'll run through a demo showing how easy it is to implement a continuous integration process with Team Foundation Server. So I'm going to jump over here to Visual Studio. And in Visual Studio, I've got a sample project set up. And it's basically a small web application. We've got a web app and a business DLL and a unit test project. And we also have a couple of installer projects. You can ignore the installer projects for now. That's going to be for part 2 of the presentation. But for now, what we want to do is we want to demonstrate that when we make a change to our code base, it's going to automatically compile, test, and deploy for us. So just to give you an idea of what the application does, it's just a very simple app that is going to go through and it's going to calculate a tip for your check. So you take somebody to a restaurant, let's say you spend $100 on the meal. You're a cheapskate, you leave a 10% tip. Should come out at $10 if everything works right, and it does. You'll see one other thing just to take a note of. I've got a special label down here showing what environment that you are running in. So since I'm running in the IDE, it's going to show local. When we actually deploy this application, I'm going to demonstrate how you can deploy it for custom environments. And I will also demonstrate how TFS will automatically transform your configuration files so that you can eliminate that manual step from your deployment process. So let's go ahead and jump out of here and let's go over to TFS. Now in TFS, you can see right now I do not have any build definitions set up. So if we double click here, there's no history because there's no builds. What I can do is I can say, let's do a new build definition. And at this point, there's a number of things that you need to fill out. First, you need to give the build definition a name. So it defaults to your solution name, I believe. And we'll just call it continuous integration. See how well I can type. The next tab you want to go to is trigger. Under trigger, you've got a number of options. You've got a manual, which basically means you can define a build that you can trigger manually as opposed to being triggered by an event such as a check-in. You've got continuous integration, which is what we're going to be demonstrating right now. You've got rolling builds, which is kind of like continuous integration, but it basically accumulates all your check-ins until the prior build finishes. So if you have a busy build server, you're not trying to fire off everything in parallel. You can kind of stagger it a little bit. You have gated check-in, which we will also talk about tonight. And the best way to describe that is kind of like continuous integration on steroids. And that is sounds like an odd description, but I think you'll understand what I mean after we go through a couple of demos. And then finally, we've got just a regular schedule where you can say every night at 3 o'clock or every morning at 3 a.m., let's go ahead and build the application. but we'll stick with continuous integration for right now. The next thing that we're going to fill out is the Workspace tab. And on Workspace, what you want to do is you want to go in, you want to drill down to your solution folder. So you can see that we have our team project of continuous integration demo, and then we have a folder that actually contains our source code. So I'm going to select that. And that's really all you have to do at this point. For build defaults, you'll see there's a little exclamation point here, and basically it's configured so that you have to either turn this off or turn it on. Right now you've got the checkbox that says whenever you do a build, I want to copy the output of that build to some folder. And it usually wants you to put the outputs to a network folder. Since I'm running this all locally, I'm just going to kind of fake it out, and we'll just have it redirect to the local laptop. Process is where some of the most important properties are set. So by default, you'll see that it will automatically try to compile your solution, which is what you want. But you will also see here that you can specify what type of configurations to build. And if you come up here and you look at the configurations I've defined for the solution, I've got the standard ones of debug and release. And then we also have a number of custom configurations, dev, QA, and prod. Now if you think about it, I'm sure most applications that you work on, if not all of them, connect to a database. So in your config file you might have connection strings, or you might have application-specific settings. In my particular application that I put together, if you look at the config file, if you remember at the bottom of that web page, it showed the environment name, and it showed local when I was running from the IDE. I've got some environment-specific or configuration-specific config files. So for dev, I'm going to show dev. For prod, I'm just going to show prod, and so on. And ideally, what we want to do is we want to deploy this application and make sure that that transform happens for us automatically. So what we are going to do is we are going to specify that we are going to build the dev configuration for this example. So if you go into the builder here, you drop down, you might be a little surprised at first because it only shows the standard configurations. But you can type in your custom configuration name, and that will work just fine. And then for platform, we're just going to put it at the default of any CPU. So that should work out for us pretty well. Moving on to the basics section, the first thing you see is properties related to your unit test. So by default, it is going to look for any assembly that has the word test in its name. And it's going to extract all the unit tests out of that assembly and run those for you upon the build. There's one property that I want to point out here, that's fail build on test failure. They set it to false, which means that if any of your unit tests fail, technically your build still succeeds. I think that's kind of an odd default, to be quite honest. And I always turn this to true. If you leave it at false and your unit tests fail, you'll get a status of partially succeeded, and you'll see an icon. It looks like a green check mark and a red X, so it's really confusing. But anyway, set it to true if you want your build to truly fail if the unit tests fail. One other thing I'll point out here, you can change the naming convention for your test. So for example, if you want to use a different naming standard for your test projects, you can do that just by changing the filter. One thing that we have done at Horace Mann is we want to specify a specific test project for a given type of build. So for instance, if we're following a best practice of having a project for unit test and a project for integration test, and let's say for a given build we only want to do the unit test or the integration test, one or the other, then we could specify that as well. So if our project naming standard was test.unit, we could put unit in here, and it would only run the unit test projects, which is a good thing to know. Moving on to the advanced section, there is one property in particular that I want to point out, and that is the MS build arguments. Now the MS build arguments it's what you need to set if you want to make the automated deployment happen. Now, there are a lot of arguments that you need to specify, and I'm not even going to attempt to type them in because I know that I would get them wrong. So I'm going to cheat a little bit. and I'm going to copy and paste those in. But even though I'm taking a shortcut, I will still explain what each one of them are. So let's go back to the slides for just a second. The MS build arguments that I'm using are these. So we have deploy on build equals true, which is pretty self-explanatory. There's a deploy target argument that you need to use. And right now I have it set to deploy publish. So that's just going to say publish my changes out to the website. There is a MS deploy publish method and a service URL. This requires a little more explanation. Your publish method, you have two ways of publishing your web applications. You have the RemoteAgent service, and you have something called WMVC. If you are deploying to an older version of IIS, such as IIS 6, you have to use the RemoteAgent service, because the newer service, WMVC, is not compatible with it. Unfortunately, there are some negatives to using a RemoteAgent. For one thing, the account that deploys to that web server has to have administrative privileges on that box. There's going to be a few administrators that probably aren't going to be too happy about that. But that is a requirement. If you try to deploy without that privilege, it will fail miserably. If you do have an IIS 7 web server and you're running Windows 2008, you can use WMVC. The advantages of that are it runs over HTTPS, so everything is run over secure sockets. The more important thing, I think, for purposes of this discussion, is a non-administrator can deploy the web application to the web server. And you actually have to go into IIS and set up some security there. But by doing that, you can give a developer the rights to deploy an application. They do not have to be an administrator on the web server itself. So that's a pretty nice feature. So what I'm going to be demonstrating tonight is actually using RemoteAgent, because I'm running everything locally on my laptop under Windows 7. And it unfortunately cannot use the WMVC service. And let me go back to my slides here. So we've got RemoteAgent, which I'll be using tonight. This is just the URL that goes along with RemoteAgent. The URL for the MS SVC, whatever it is actually a different URL, and you will see it prefixed with HTTPS. There's another parameter here for create package on publish. That will create an actual installation package. I believe that is also required to do the transforms. I'm not 100% positive about that, but I believe you have to have that specified for the transforms to occur. And finally, this last parameter looks a little odd. It's username equals blank. The reason I have it set up this way is that will basically force the build server to use the account that the build server is running under. It will force it to use Windows authentication to connect to the web server. Now, you could specify your own username and password in there. That would be a very bad idea, because if you do that, as soon as you save it to the build definition, then everybody knows what your user ID and network password is, so don't do that. You could, again, typically when you set up a TFS build server, you are going to have like a service account or a domain account that you're going to set up. You don't have to specify the actual username and password for that. Just leave it username equals blank, and it will work just fine. It will by default use the ID of that account and connect through Windows authentication. Now, one thing that kind of bit me when I was trying to do this, and the documentation is not ideal from Microsoft on this. If you say username equals empty, like quote quote, it doesn't work, because it tries to use an account name of nothing, or quote quote. So anyway, just a lesson learned. Save you guys a few hours of banging your head against the cubicle wall. So back to Visual Studio. I think this is everything that I need to set for this build definition. There is one other tab. I have never messed with it, but it basically indicates how long you should keep your history on your builds. So you can configure that if you like. So let's go ahead and save this. And if everything is set up properly, then whenever I make a change to this web application, it should build, it should run the unit test, and it should deploy. Now, just to show that I'm not doing a smoke and mirrors show up here, because I know some of you guys are thinking that, let's go out to IIS, and you'll see under the default website that there are no websites actually, or web applications actually defined out in here. There will be after the deployment is finished. Now, one question for you guys, we'll make this an interactive show this evening. How is it going to know where to deploy, which server to deploy the web application to? And for that matter, what web application name? I know you know. Does anybody else know? Okay, well there are two ways that you could do it. You could actually specify as a parameter on MS Build that the actual URL that you're going to deploy to. Again, that's a bad idea. You really don't want to do that. The reason for that is if we go back into the build definition, oops, you'll see that we can specify configurations. So we can do more than one, right? So if we were to specify, say, dev and QA, we want to just knock it all out there at the same time. What's going to happen is it's going to compile the dev configuration for the solution, and it's going to deploy it to that URL that you specify in MS Build arguments. Then it's going to compile QA, and it's going to deploy to that same URL. So it's just going to overwrite right on top of it, wipe out the first compile.
Smart answer. What's the problem with that?
So the way to get around that is to actually go into your project properties, and you will see that there's a package/publish web tab on your web application. And if you scroll down a little bit, you'll see that there's a property called IIS website/application name. And that is actually, you can change that per configuration. So you'll notice here for dev, I've got the default website/tipcalc dev. QA, I'm going to have the QA name, and prod, I'm going to have prod. So let's see if we know what I'm talking about here. Let's go ahead and make a change to the web application. Oops. And we'll just make some minor change that's not going to cause the unit test to fail. So we'll go from that nice slate bluish background to something really hideous like red. We will save that, and we will check it in. Give it a comment, change code. Now at this point in time, if you go out and you take a look at the build definitions, you can go to the queued tab, and if you see that green arrow, that means it's working. That means the build is actually executing at this point in time. And if you double click on it, you can drill in and actually observe the process, observe the details of that build. It's interesting for about 5 seconds. I get pretty bored. But this will show you if there are any errors that occur during the build process. One thing that this will do after the build is finished is that it will actually take away all the detail. And if there are any errors, it will show, oh, we already have a problem. Okay. It will do exactly what I said it would do. It will take away all the details for the build, and it will give you a nice little error message here. Now, I actually had this earlier when I was playing around with it, and see if I can remember how I fixed it. I haven't actually seen this happen at Horace Mann, but I've had it happen on my laptop a couple of times. I believe, since I've been messing around with this demo, that when I've removed the build definitions and re-added them, sometimes TFS gets a little confused. Let's test out that theory. So I probably used this name before. So we'll just call it CI. I don't think I've used CI before. If this doesn't work, this is where I start to sweat a little bit. But let's attempt to check that in. Actually, it did already check in. Let's see if we can kick off that build again. Brandon, you have any Jeopardy music we could play? Okay, this looks good, actually. All right, we've already gotten down. You can see right here what it's actually doing behind the scenes. It is running MS Build for the project. So behind the scenes, it runs MS Build in the background. I think MS Build was a little more prominent in previous versions of TFS. I don't have very much experience with, like, say, TFS 2008, so I can't speak to that too much. But just be assured that it does run MS Build in the background. So it compiles, and now, okay, everything has worked. So you can see now that it gives you additional details. So for instance, it has run the unit test, and you've got 5 out of 5 tests that passed. That's a good thing. And we can actually click on that, and it should bring up the test results. So we have our 5-unit test that we have defined. You can actually, from this point, right click and you can open the test and go right to the source code. Oops. And then if there's an error, you could go to the test results details. It'll show error here, and there will be an extra section here that describes the error in more detail. So for instance, if one of your asserts failed in your unit test, or your code threw an exception unexpectedly, you will see that message here on the screen. And then you can go investigate it and hopefully fix the problem. One other thing that you'll notice here is that it will automatically do code coverage for you as well. There is a little bit of configuration involved in that, but it is nice to know exactly how much of your code was covered by your unit test. And you can actually right click on the test, go to code coverage results, and I just happen to have 100% coverage on these. And sometimes you get some goofy error messages. I've had this one that comes up saying a format's unsupported, and then it pulls the window up. So I'm sure a future version of TFS will fix that. I don't know if how well you can see it on the screen, but there is some color coding here. The blue indicates that it was actually covered. There are other color coding that would indicate that code was not covered by your unit test. So far, we have automatically built the application, and we've automatically run the unit test. So 2 out of 3 so far isn't bad. Now we need to see if it actually deployed out to IIS. So we'll come out here, and we will refresh our default website, and there we go. It has been deployed to the application. Now, just one other thing that I mentioned before was that TFS should have automatically performed the transformation on the config file. And we had one setting in there that would actually be changed, which was the environment name. So if I go out to the dev website, you'll see now, besides the really nasty background color, that it did actually transform the config file for you. So pretty cool. We have that this process established at Horace Mann, and it's actually been very helpful, very good time saver for us. So at least for the SAL team, we're working on other teams. Now everything looks great, and at first glance you might think, man, this is awesome, and it is. But there are some things here that you need to be aware of. If we stick with the continuous integration template, the continuous integration build definition, there is a potential issue. So let me go through, and I'm going to deliberately break some of my code. All right. So I'm going to take the calculation that I was using to calculate the tip, and I'm just going to put some random number in there. That's really going to throw off the tip calculation. And what I'm going to do now is I'm going to check this in. So we check it in. I will go ahead. I'm going to give it a comment so we can track where it is in the version history and source control. So I would say deliberately broke calculation. Now, if I was following best practices, I would run the unit test before I checked it in just to make sure my code worked. But got lazy. I had to leave early for the day, whatever. So I'm going to check the code in and let Paul deal with it later on. So what you'll see here is we're going to go to the build definition window again. It's going to run. Shouldn't take as long this time. Once the build agent gets loaded up, it actually runs pretty quickly. At this point, should be getting ready to run the unit test. It is. It's running MS test. And any moment now, it should show that probably 3 of the 5 tests have failed. Okay, 2 of the 5 tests have failed. No, 3 did. I'm sorry, I misread it. 3 failed. So again, you can click on that, and you can see which test failed, which is a nice feature. Here's the problem. It actually did check the code in. So at this point, anybody else in my development team, they go to grab the latest version of the code, they're going to get this erroneous code. So that is kind of the drawback to using just the standard continuous integration template. Ideally, what you want to do is you'd like for it to detect that there was a problem and roll back that change or not allow the change to go in the first place. And there is a way to do that. And that's what I'm going to demonstrate next. So we're going to come over here. I'm going to cheat here a little bit again. I have the TFS power tools installed. So rather than create a brand new build definition, I'm going to right click and say clone. That way it just copies all the properties over from the previous build definition. I'm going to change the name of it. And hopefully I won't pick a name that I've used previously, because obviously that causes a problem. I have to remember that one for Horace Mann. And we'll change this to gated build name that I haven't used before. Whatever. Okay. We'll go to trigger, and we're going to change this now to the continuous integration on steroids option, which is the gated check-in. Now, the difference between continuous integration and gated check-in is gated check-in does what it says it will do. It will actually put kind of a gate at the front door, and it will run the unit test, and if any of those unit tests fail, or if the compile fails, either one, it's going to say, you know what, your code's not good enough to get into this source control database, and it will actually stop it. It will put it on what's called a shelf set, and basically that's just a temporary holding area for your code. So let me go ahead and demonstrate that. Actually, before we do that, I need to fix my code. Otherwise, it's probably going to complain. So I'm going to disable this temporarily. All right, so I will fix the calculation. Oh, and just to demonstrate that it did actually check it in, if you go and you look at the history, you will see here where I deliberately broke the calculation. So it did indeed get checked in. All right, so I'm going to fix this. I'm going to check it in. We'll let it run through the normal build. And this one should go through just fine. Alright, we will enable this now. So now that the code is fixed, as soon as I get another error, it should stop the code from being committed to source control. We'll just make sure that this completes first. It should only take a second. Okay, we are good. All right, so now I'm going to go and I'm going to break the code again. And we'll throw the calculation off even more. So we're going to check it in. We are going to say break tip calculation one more time. We're going to check it in. Now, you'll notice a dialog has popped up. That dialog says, I got to validate your changes before I'm going to commit it to source control. That's the gate that pops up when you try to check it in. There are options that you can specify. One is preserve my pending changes locally. So basically, when you check your code in, you have the option to keep those changes in your local workspace. And then you can continue on from there. Or you can say, you know what, I don't want those changes in my local workspace. So it will actually undo all the changes that you've made, and it'll stick it just over on the shelf set. And so it'll still be there. So if something fails with the build, you can unshelve that code back into your local workspace and start working on it again. or you can just leave it in there in the first place. There is another option that you should never be allowed to check. That's bypass validation build and check in my changes directly. Yeah, I still have that, by the way, Paul. What that will do is, obviously, that allows you to bypass the validation. Normally, a developer would not have that option. I have that option in this setup because I'm also administrator for TFS. So by default, I'm going to be able to do pretty much whatever I want. But under normal circumstances, you would not want to give your developers that privilege, in my opinion. So we'll go ahead and build. And just a few seconds, it should show that the unit test failed. And then we will verify that the file indeed did not get checked in to source control. Okay, so we can see that it failed. It should come back here just a second. All right, it failed. You can see the test results. We already showed you that. You have an option up here now that you didn't before, and that's called unshelved changes. So if you did not keep your changes in your local workspace, you can click that link, and it will pull it back from that shelf set back in so you can fix whatever problem you've introduced to the source code. If you look at view history now for the build.cs file, the last version was where I fixed the calculation, not where I broke it again. So it indeed prevented it from being committed to source control. Now you'll see here, I forgot to mention this a while ago, there's a utility that comes with Visual Studio. It's called the Team Foundation Build Notification. You can open that up and configure it for a given type of build. You can say, I want to be notified when either I or anybody on my team has started a build, finished a build, or just queued one up. And that's kind of a nice feature because then you can basically be made aware when anybody on your team has submitted changes to source control and has kicked off a build. And that's what popped up right here, this little gated check-in. And it told me that the gated check-in was rejected, so at that point I have the option to unshelve or ignore. Now, there's one thing I'll bring up here, just a little gotcha. When the build succeeds, you'll get a notification as well. And the button will have a different title on it. It'll say reconcile changes or something to that effect. My experience has been, at least on my laptop here, when I click reconcile in this dialog, it doesn't actually reconcile the changes properly within the IDE. But if I click on the link that says reconcile changes in the build results, it works fine. So just be aware of that. You might run into that yourself on your own configuration. So anyway, at this point, I will go in, I will go ahead and fix the code. Once again. Oops. And say final fix for calculation. Fire Scott later. Alright, so we'll build, and this one should go through just fine. Now there's one more thing that I will bring up before we take a break, and that is there's one more little fly in the ointment here, so to speak. If you remember, there are 3 steps to this process. You build, you run the unit test, and then you deploy automatically. Unfortunately, those steps don't run in that order. So what TFS does is it builds, it deploys, and then it runs the unit test. I don't understand why they define the build template in that way. It might be because it uses MS Build behind the scenes, and I know they've integrated a lot of the web deploy functionality into MS Build, so it probably builds it. It's like, okay, the compile is good, we're going to shove it off, and then it runs through the steps to perform the unit test. But be aware that if you do have it set up for automated deployments, you could run into a problem, and if your unit tests fail, your code is still going to get deployed out to your web server. That was something that we didn't realize was happening until it happened the first time, and we're like, hey, what's going on out there? So There's not a good fix for that. You can't just go in and set a couple properties and say, I want this to work differently. I will give you a hint, and that'll kind of lead into the second part of the presentation here. The way to fix that would be to actually modify the template for the build definition itself. And you would basically have to take control away from MS Build and do the deployments programmatically on your own within the workflow for the template. I'm not going to do that tonight. We'd be here for 4 hours if I did that tonight. But just to give you a little hint that that's probably the steps that you would have to take to resolve that problem if it is a concern for you. All right, we'll move on to part 2 of the presentation now. We're going to take a kind of a behind-the-scenes look at the actual build process itself. The build processes are in TFS 2010 are based on templates, which themselves are based upon Windows workflow technology, which I think is a pretty big departure from previous versions of Team Foundation Server. So we mentioned a couple of, or at least one scenario where we might want to customize the build process. The specific scenario was where it will actually deploy the code before it runs the unit test. That might be a good reason to go in and change the build process around. If you need to do that or would like to do that, you can do that pretty easily through Visual Studio. There is a workflow designer for Windows Workflow, and so you can go in and manipulate the actual build process itself that way. Or you can jump into the raw XAML code if you happen to feel more comfortable changing things using that method. If you do decide to manipulate your build processes, Visual Studio will give you a number of predefined activities that you can use. And I'll show you examples of those here in a few minutes. And if for some reason those predefined activities don't meet your needs, then you can actually create your own custom activities in VB or C#, and you can import those into TFS and use those in your workflows. And I will say that the predefined activities are pretty extensive. There's a lot of functionality there, so you may never need to do that. For the customizations that we've made at Horace Mann, I did not have to go that far. There was enough built-in functionality that we were able to do what we wanted to do. So before we jump in and look at the workflows, let's just get on the same page as far as what some of the definitions are for Windows Workflow. A workflow itself is basically a series of steps defined from start to finish. The series of steps, the steps themselves are called activities. You can think of an activity as a unit of work. Another common term in Windows workflow terminology is a sequence. A sequence is just a collection of activities. So for example, if you introduce a conditional statement in your workflow and you say, if this condition is true, I want to execute this series of activities, else execute this other series of activities. You have to wrap those activities in a container called the sequence. And you'll see that as we dig into the templates in a few minutes. Just a couple other things. If you need to store data within an activity itself, you can define variables. And if you need to move data into or pull data out of an activity, then you would define arguments. So why don't we jump over here to Visual Studio. And we'll get rid of this stuff. We don't need it anymore. If you go into Team Explorer and then you drill into source control, take a look at your team project. TFS by default will create a folder called Build Process Templates. And there are 3 templates that it will put in there by default. One is called Default Template, and that's actually what we've been using all night. Every build definition that we have created tonight has used the default template. Lab default template, I honestly don't know much about. I haven't messed with that at all. Upgrade template is for users of prior versions of TFS. That gives you kind of a migration path to the current version of TFS for your builds. But let's focus on default template for right now. If you double click on default template, it will bring up the actual Windows workflow itself. Now on slower machines this takes forever, so you might want to go get a soda and then come back. Okay, at first glance it doesn't look too bad because you see the first part of the actual build process, the workflow for the build process. And you got a nice big handle on your scroll bar, so you think, oh, I can flip through that here in a few seconds. Looks are deceiving. because if you start actually scrolling down a little bit, Visual Studio will start expanding all the tasks and the subtasks and the sequences, and it gets to be immense. Yeah, I mean, on a widescreen monitor, you can't see it all, you know. So anyway, that looks a little daunting, especially if you had every intention of going in and changing this template around to customize it to your needs. You might turn around and run away screaming. But before you do that, the best thing to do is collapse everything down, try and get a handle on it from a high level. So at a high level, you can see the basic steps that the build process is going to perform. There's a step called get the build. I'm assuming it's going out and getting the source code. It says update drop location. If you remember when we defined our build definitions, there was a property in there called drop location. It's going out and just basically grabbing that property. And then you have run on agent. That's where it actually will do the compilation and run the unit test. And then the last step here is check in your gated changes, assuming you have a gated check-in defined. So just briefly, we'll go through and we'll kind of drill into it and see how it actually performs the compile. If you double click on run on agent, you'll see in a lot of these sequences it'll do some initialization, and then towards the bottom it'll perform the main task. So you can see here that you got to keep digging if you want to see where it actually compiles your solution. So we double click, we're going to double click again. You can see here we do a compile and test, and then there are some other tasks that it performs. Keep digging, get in there, and you can see here that they're pretty descriptive. It's going to iterate through all the configurations that you have defined in your build definition, and then it will compile and test for each configuration. It'll iterate further through all your projects. It'll try to compile the project. And then you finally get down to the very end, and you have this sequence called compile the project. And you can see here where it does a little bit of initialization, and then it actually runs, this is where it runs the MS build process to compile your solution. So there is a lot of steps to the process, but let's say that your intention is to go in and customize the build because you want it to perform some action after it compiles your project. Well, if you drill down all the way to the bottom, then what you would do is you would break out your toolbox at this point. Oops. And you can see that there are a number of activities that you can start popping in here. So for instance, the very first section, you have team foundation build activities, and you have all kinds of things that you can do. You can copy or create directories, you can check in changes, delete directories. Let's see what else we got. You can actually write out messages, so you can build messages, build warnings or errors. And if you remember when we were watching the build occur within the IDE, these activities are what write those messages out to that window. And then finally, there's a really handy one that I have used called invoke process. So if as part of your build you need to go out and run some random utility to perform a function, you would use invoke process, and it'll shell out and it will call that utility for you. And I will show you an example of that here in just a few minutes. So assuming at this point that you're still willing to go in there and modify the build, you may kind of ask yourself, well, why would I want to do that in the first place? Well, we had one example already where the deploy fires off before the unit test. That might be one reason you want to do it. Here's another example for you. I know at Horseman we've got a number of Windows installer projects that we have to build, at least for the system that I work on. MS Build does not natively support Windows installer projects. So, for instance, if I were to try and run the build that I ran before, but I would have specified a different configuration, like say my QA configuration, that included those installer projects, you would get error messages during the build. It wouldn't stop the build. It wouldn't cause the build to fail. But you'll get warning messages that basically say MS Build doesn't support this type of project. You're out of luck. So one thing that we have done for our system, for the SAW system at Horseman, is we have actually went in and added compiler or compilation support for Windows installer projects. Now, let me give you a little hint. When you're setting up your build server, put Visual Studio on it. You are going to need that. 2 reasons. One, MS Build, like I said, is a little bit limited. The installer support aside, when I was testing this at home, I set up kind of a virtual network, and I had a build server, I had a web server, and I had this web application project that I was working on. I tried to deploy it, and MS Build basically puked because it couldn't handle a web application project. So I did a couple of Google searches, and they basically said, well, actually this was a response from Microsoft. They're like, well, that is a limitation. Just put Visual Studio on your build server and you'll be fine. So, okay, assuming that you have the licensing to cover that, you would do that. And I did do that at home. And as soon as I put Visual Studio on there, it worked fine. It was able to compile all the web application projects that I threw at it. Now, that didn't fix the installer support. I was not able to compile any installers just by adding Visual Studio alone. So what we did at Horseman was we basically modified the template so that it would specifically call into Visual Studio, fire it up, and then actually compile the installer for you. Okay. So my intention tonight was to walk through that painfully, step by step, and show you how to do that. I don't want to put you guys through that. There are a lot of steps to it. But what I would like to do is just kind of give you a high-level overview of the changes that I made to the template, just to kind of give you a kickstart in the right direction. And then by doing that, hopefully you can take that and run with it and put that type of functionality into your own build templates. So what I have here, I've created another template. And let me give you a little hint here. If the easiest way to create a brand new template is to go in and let's pretend like you're going to do a new build. No, I'm sorry. Pretend like you're going to create a new build definition. If you jump down here to the process tab, you'll see this little section that I kind of skipped over before. This is your build process template. And by default, it uses the default template. But what you can do is you can select a different template that meets your needs, and you'll have the default upgrade or the lab default in there. But if you want to create a new template, you can click on the new button, and you can actually create a copy of a template at that point in time. So you can come in here, and I usually leave these at the defaults, assuming it's pointing to the correct template, and you can give it a new file name. Excuse me. And when you click OK, which I'm not going to do right now, but when you click OK, it will actually put this new file out here for you in source control. Now, you won't have it locally. It will just be on the build server. So if you, as soon as you want to start making changes, you'll have to right-click and get the latest version or check it out for edit. And then you can start working on it at that point in time. One other thing that will bite you if you're not careful. As soon as you start making changes to the template, you can click Save, and then you can try to go and run with the new build definition, and it's not going to see anything. You have to check that build template into source control before any of the changes will actually take effect, because TFS, whenever it runs your builds, it's going to go out to source control and grab the latest version of that build template. I spent a little time on that the first time. I made some changes. It didn't cost you guys much, don't worry about it. So anyway, let's go over some of the changes that I made to give the default template installer support. There's really 3 things that we want to go over here. If we bring it up and take a look at it, it doesn't look much different at the very beginning. And the changes I made were actually in 3 places. One, I've added 2 arguments to the overall process. And let me sort these so that I can find it pretty easily. I added 2 properties. One is called Visual Studio Server Path, and this basically will tell the workflow where Visual Studio is installed on the server. That way we know what executable to call whenever we want to actually build the installer. Now, you can give it, you tell it what type it is. It's just a string because it's just a path and a file name. And you can even give it a default value. So if you know where it's installed and you don't want to have to specify that every time, you can just plug that value in, which I have done here. One thing that I will point out, and this is very important because it might have you scratching your head too. There are two dev environment programs. There's an executable and there's a .com. Use the .com. If you use the executable, that's actually the GUI, and it will work. You can actually use it to build your installers, but if there are any problems when it tries to build the projects, it will eat the error messages and you will never see them. However, if you point to .com, it will actually, I assume what it's doing is it's putting the error messages out to the standard console, and it picks it up and it displays it on your build window itself in the build output. So always use the devenvironment.com. The other property that I added was this thing called MSI projects. So this is basically our installer projects, and it is an array of strings. And once you make these changes and you actually save it and check it in, which is very important, then when you go in and you create your new build definition, which I will do, actually I'm going to cheat. I love this clone feature. Let's call it installer build. I don't think I've used that name before, so we should be safe. We're going to change to default template with installer support. You will see the two new properties now. So you got your Visual Studio Server path, and you have the MSI projects. MSI projects is blank because obviously it's going to be different for each solution. I didn't get too fancy with this because I didn't want to spend a whole lot of time on it. But since it's an array of strings, it basically gives you this generic string collection editor. So what we would do to actually specify our projects, the way that I have the build template set up, is you would specify the project name and then the project file. So tip calc.installer, and then you need to give it the actual project file name. VD project. And we have two, so I'll put the other one in there as well. So now if you pop that down, you see that those values are in there. Now this is actually better than what I did at Horseman, because at Horseman I did something really cheesy and I limited it to 3 installer projects because I wasn't sure how to do this, but it's an enhancement. I'll bring that to work tomorrow. So anyway, we now have these properties that we can specify for the installer projects. That by itself is obviously not going to be enough to tell it to build the installers. So that's where we have to really dive in and customize the build process a little bit more. Let's go ahead and jump back in there. I'm going to drop this back down so we have a little more real estate on the screen. And if you double click on Run on Agent, and actually if you remember where I went before, which is why I went down that path, all the way down to where it runs MS Build. See if I can remember how to get there. What would be nice, and maybe there's a way to do this, if you could have bookmarks so you could just go right there, that would be awesome. Okay, oh, let me back up here a little bit. All right, so here's where we stopped before. We had this compile the project step, and it would run MS Build for the project. I've inserted, if you look here, a sequence, which I grabbed from the toolbox. Not here, but it would be under control flow. I added a sequence because I knew I was going to execute a series of steps. And if you drill in a little bit more, I've got a for each, so it's basically going to go through those installer projects that I specified into properties. It's going to go through each one and iterate through them. And then it's going to call this build MSI sequence. This is we have a conditional here. Let me go ahead and expand this a little bit. So basically we're just doing a little error checking to make sure we don't have a blank line in that string collection editor, because I didn't get fancy with the dialogue. And then we have another sequence called create installer. So here we have an activity. This is one of those predefined activities called invoke process. This is the kind of get out of jail free card, because if you can't find another build activity that will do what you want, but you have like some utility program or something that you know will do what you need, then you can drag over invoke process, that activity, and configure it to run whatever you need it to run. So if you look at the properties for build installer, and this will require a little bit of explanation. I've got some variables and things defined, but essentially, just trust me on this one. It's eventually going to grab the information from that property specified for the server path and the path to the IDE, essentially on the build server, and it's going to execute Visual Studio on the build server. Check one thing here. Let's do that to me again. There. So if you look really close, you can see where it's actually passing the arguments to the IDE. So you can tell it what it's going to build, tell it which configuration it's going to build, and it grabs that from the workflow, the actual. So like if you tell it to compile installers for QA, it's going to be able to grab that information from the workflow and create the QA installers for you. And it also passes the project path as well. And oh, here it is, the file name, Visual Studio Server Path. That's what it's going to try to run. So it's going to call Visual Studio, it's going to build the installer, and then we have a little bit of error handling. I'll dig in here. It will write any output from Visual Studio, so whether that installer succeeds or fails, you're going to see the build output within the results of the build, in the build window, I guess you would call it. And if there's an error, it's going to grab that error output. Let me go back here. And it's going to go down to this next step where it checks the exit code from that process. So if I remember right, it's checking basically the exit code from Visual Studio. And then we're gonna write the build error out, and then we're gonna throw an exception. And Visual Studio will catch that and handle it appropriately. So that's step 2. That's where it actually compiles the installer files. So at that point, what do we have left? Well, we have to find those MSI files, and then we have to copy them somewhere so that we know where they're at. And if you remember earlier, we had a drop location that we specified in the build definition. So I've configured the template to basically go out and find the MSI files and copy it to the drop location. That way you can then either tell your administrator where to go grab them, or you can just copy them somewhere where somebody else needs to pick them up. So we will drill down into that real quick, and then I will run an example and show that this does indeed work. Go back in here. All right, so we're going to start going down the same path. I miss this every time, so I probably will miss it again. Oh, I found it. Here we go. For this sequence, you see down here, this is a try-catch finally. So, I mean, if you do VB or C#, then it's a pretty familiar construct. But within the finally and the catch, you can add code and sequences and activities as well. And when you do, it will actually put a little description off to the side, and it's real easy to miss. I miss it almost every time I drill into this. But for the finally, for this compile, test, and associate change sets activity, if you drill into the finally, you'll see that we have another sequence here. And there's one called revert workspace for shelf set. It's not really applicable to this discussion. But then we also see, is there a drop build and drop location property set? If so, it's going to go into this code right here. And there's a sequence here called copy files. I did not put that one there. It was there by default. And because TFS, the default template, it will go out and look for everything that you built and copy it to this drop folder. So I've added 2 more steps to that. I've added an activity, which was over here in the toolbox, called find matching files. And I dragged that over here and configured it. So we got find MSI files, and then you give it a filter here. Let me pull that up here. I've given it a filter so that it looks for everything that ends in .msi. and it's looking in something called the sources directory. And then there's a result called MSI files. It's basically going to be a list of the MSI files that it found, and then that is going to get picked up here. So you see here that we do a for each on those MSI files, and we just iterate through each one, and we do the really handy invoke process, and we do an xcopy. So we xcopy each MSI file out to the specified location, and then we're done. So let's see this in action. I will come back in here and we'll do the installer build. I'll go in here and configure this. We'll just do it manual. We don't need to do a check-in or anything. We have our drop location specified. I'm going to go clear out the drop location because we probably have a lot of junk over there right now. Yeah. Okay. Then on process, let's see what we got to do here. Right now it's configured for dev. It was actually our QA configuration that had the installers included, so we're going to switch that over to QA. We have the installer projects already specified, so that's good. We don't need to run the unit test, but we can. And I'm going to remove the MS build arguments for now because we don't really need them just for this particular demo. Okay, so we've saved the changes to the installer build. At this point, if everything goes right, double check something here. Yeah, we're good. At this point, if everything goes right, when the build finishes, you should see 2 MSI files sitting out in that drop folder. So let's go ahead and kick this off. We're going to queue a new build. We're going to grab the latest source code. We're going to drop it in that folder. You notice you can override some of the properties whenever you kick off a build manually. So you've got a few things in here that you can override the defaults. There's the MS build arguments that you were asking about earlier, David. You can actually override those there. Click Q. We're going to watch this. As unexciting as it might be, I do want to demonstrate that you can see the output from the MSI build to kind of prove that it's happening. So far we're running the build for the solution. Now these are the steps that I added. Build MSI, if the project is specified, and so on. And you can see here it's calling the devenvironment.com. Oops, and passing the project file and a bunch of other parameters. It's also passing the correct configuration. It's grabbing that from the workflow. This one might take a little bit longer. There we go. So you can see now everything actually looks pretty good. This is the output from Visual Studio that you would normally see whenever you compile the MSI manually. Now, okay, one thing I want to point out here, it took all that away. We'll go back and take a look at it. Because I had the installers checked as part of the solution, MS Build still attempted to build those installers, and it just gave warnings. It didn't fail to build, but it did go ahead and give you the warning messages. And I haven't tested this, but I would think technically you wouldn't even need to include that as part of your solution. You could probably just specify in that custom property which installers that you want, and then you won't even see those warnings. But let's go and look at the full log, and you will see that once it got down into the MSI specific section of the workflow, then it built a project. You can see the output from Visual Studio. Warning I'm not going to worry about, but it did build the MSI, and then it packaged it up. And it should have done that twice, which it did, because we had 2 installer files. And then it went on and did its normal stuff. And then at the very end, you can see the other customized part of the build process. We've got copy files, which was already there before. but we've got our custom steps of find MSI files and copy those files to the drop location, and it just drops out and runs the command line xcopy, or the xcopy command. So at this point, we should be able to go out to the drop folder. Now, two things here, and I neglected to demonstrate this earlier. Whenever you have your drop folder, your websites are going to be in a folder called Published Websites. So if you drill into that, you'll have your actual web app. So you've got your bin folder with all your binaries, you've got your web pages, and you have all your config files. I'll just mention briefly that these config files are not transformed because it was not an automatic deployment. There is a way to make it transform by modifying the project file, and I can actually go over that later on after the presentation if you would like. But jumping back to the main directory, for some reason Visual Studio, or TFS rather, insist on putting all the binaries in the main root folder. It drives me nuts. I never use them for anything, but they're there. I guess if you need them, you can use them. But the one thing I want to point out is this QA folder. The way I customized that build template was I said for each configuration I want to create a separate folder with the name of that configuration. So if I would have specified QA and prod, I would have a QA folder and a prod folder in this drop location. You drill in there, you've got QA, you've got MSIs, and boom, you've got your MSI files. So that right there kind of shows you the power that you have with the Windows workflow and with the ability to customize these build processes. You can make it do pretty much anything that you want it to. The biggest hurdle for me was just learning Windows workflow in general, because I had never worked with it before until earlier this year. But it's really not too bad once you get into it. So at this point, I think I've covered just about everything that I wanted to cover this evening. I'd be happy to take some questions now, or I can take them after the presentation as well, whichever you guys would prefer. But anyway, I would like to thank you for coming. I hope I presented you with, or presented enough information for you to take and run with it and use in your own development environments.